Hi. My name is Jeethu, and my handle on Numerai is JRB. And I've been involved with Numerai since about 2016, so about 10 years now. A lot has changed since the early days. I think traditionally we've had like two camps in the Numerai data science world. Just like with every other field. So there are the neural net people and the tree people. I, for the most part, have been a neural net person. And so I was at this NemoCon event, and I have developed some mild sympathy for the tree camp. So I figured I will do something about it. I think a lot of you guys were at NemoCon. And I think the three biggest takeaways I had from NemoCon were, first thing was I got white coding built. I had a lot of people working with me who were white coding and things, and I wasn't exactly a fan of white coding, just too much review overhead and things. But then I had a change of hearts and seemed to be liking white coding a little more. Although I probably wouldn't be white coding smart contracts and things like that. So I hope the atomic staking contract update will not be white coded. But otherwise, anyway. Second thing was I learned that a lot of people are using the Numerai upload feature, the model upload feature. I personally never quite liked it, but it seems like the community likes it a lot, which is quite surprising. Third thing was I had a conversation with Tim, who's known as Jeffrey the Wind, who's here. And he told me about this. So I think he's been doing a lot of very interesting work around IRM and things like that. I read his paper from a couple of years ago about, invariant tree models and things. And I learned that he's built a GPU-based training, a complete gradient boosted tree ensemble thing called WalkGPM, which is very impressive. I couldn't wait to go home and try it out. And one thing I learned was that it only runs on the GPU, and this Numerai compute thing is CPU only. And your models have to be pickles, Python pickles. So I figured, what if you could get these things to run on CPUs? So it's not exactly a new idea. There's this thing which is I used to work in ad tech a long time ago.
So go back.
Oh, sorry, keep that line, I should have moved. So I used to work in ad tech, and trees are all the rage in ad tech, especially for ad targeting things. And there's this library called TreeLight, which can essentially take your tree models and compile them into a sort of binary format, and you can also compile them into machine code. You can build shared objects. And not just that, you could also give it a sample of your data, and it will actually make these things go faster using hints, right? So, because trees essentially are, gradient boosted trees are ensembles of trees, and trees essentially are if-then-else chains. So it's fairly straightforward to map from trees to code in any language. Although for Numerai compute uploads, your models have to be Python pickles, which is a huge impediment in my opinion. I just white coded this thing called GVM2Pi, which can take WalkGVM and XGBoost and CatBoost and what was the other one? Like GVM, and also these Numerai upload pickles. And it generates a Python file for you. I think the example model, the example model, if you just try to convert it, I think it's about 6 megs in size, and it becomes like a 13 meg Python file. Extremely slow in execution, but normally it works. Maybe I'll build a few tree-based models and use it myself. I haven't used it. You can download it from my GitHub. Probably move to the COE GitHub. So that's it. A couple of possible improvements. Use NumPy for vectorization. and tried exporting it to the tree-like runtime. The NumRI compute Docker image ships with about 169 Python libraries, including a lot of GPU libraries like Triton and things like that. I don't know for what reason. But tree-like is one of the libraries that they ship. So it should be possible to directly target tree-like instead of just Python. It should be a bit faster. And the third thing would be to convince NumRI to accept tree-like models instead of pickles, or along with pickles, because it's so much more efficient. Yeah, so that's it. Thanks very much.
I have a question. So, like, well, I've created my own CPU-based inference class that actually works with model upload.